Hi everyone, welcome back to another ThinkSphere physics video. Today we will explore the components of vectors. As we know, vectors are physical entities which denote certain magnitudes with their particular direction. However, the direction of vectors may not necessarily always be horizontal or vertical. Oftentimes, it is slanted or diagonal. So when we encounter some vectors like that, we need to figure out a way to mathematically tackle them so that we can utilize them in problems such as projectile motion. The technique we are using is called resolving vectors, which require some basic knowledge about primary trig ratios, which are sine, cosine, and tangent. Without further ado, let's look at this vector right here. It is said to be 23 degrees above the horizon, which is the same as saying it makes an angle of 23 degrees with the ground. The key idea behind resolving vectors is that we want things to be as straightforward as possible. So ideally, we would like to see vertical and horizontal quantities instead of this hideous slanted entity. So how do we do such a thing? First, we need to recognize that each vector on a 2D plane has two components, one horizontal, which is on the x-axis, and one vertical, which is on the y-axis. To visualize, we can simply construct a right-angled triangle to illustrate both components. So where is the right-angled triangle? So this would be the y-axis, and the ground would be the x-axis, and this would be the origin. So where are the two components? So we can see this is the vector right here, and the x-axis component, which is the horizontal component, would just be something on the ground. And the vertical components would be on the y-axis, something like that. And they make a right angle here. So this, we would say it's a horizontal component of this vector v. And this is the vertical component of vector v. So to achieve our goal of utilizing the vector to its full potential, which is to resolve this vector into two components, we need to actually calculate the magnitude of both components. And here is where the primary trig ratios come into play. So let's say the magnitude of the original vector is 50. We would like to know the magnitudes of both the horizontal component and the vertical component of this vector. So if we use sine and cosine to calculate the ratio of this angle 23 degrees, we can get two ratios like this. So we have sine 23 degrees equal to opposite over hypotenuse. So we have Vy over V. And we will have cosine 23 degrees equal to adjacent over hypotenuse, which is Vx over V. And using this sine ratio right here, we can rearrange it to get Vy equal to V times sine 23 degrees. So we simply just multiply a V on both sides. And similarly, for this cosine ratio, we can get Vx equal to V times cosine 23 degrees. And what we do here is we also multiply V on both sides. So we will obtain these two equations like this. And now we can just simply substitute the magnitude of the original vector v into these two equations, which will give us 50 sine 23 and 50 cosine 23 degrees. Oops. And this is how we can calculate the two components, or to resolve these two components of the original vector v. Key takeaway from this video. 1. Every vector in a 2D plane has two components, one horizontal and one vertical. 2. By using primary trig ratios, we can calculate the magnitude of both components. In the next video, we will implement a technique of resolving a vector on one of the most common types of kinematic physics questions, projectile motion. So be sure to check it out. Thank you for your time, and if you found this video helpful, please consider like and subscribe. See you next time.